Well, hi everyone. Thanks so much for showing up for your learning. I had a great question about how we go from graphs to equations. This is new and it's not that hard. You are very strong mathematicians. I've worked with a lot of mathematicians and you all are very strong for your age. You just haven't been introduced to this yet. Okay? So I'm sure you're all familiar with this type of equation. 5 equals x minus 3. This is one equation, one unknown. We just solve it, right? So I would add 3 to both sides, and then I get this nice equation. 8, come on, 8 equals x, and I'm done, right? But what if I had this situation? The value y is equal to x minus 3. Now I have two unknowns and only one equation. I can't solve it. I only have a relationship between x and y. And it's not hard to cook up an example where we might see something like this. Like, let's say I want to know how much money I have, y, and I make 10 pounds an hour. If I put in the number of hours I work there, it produces the amount of money I have. Oh, but what if I already have a little bit of money? So then I might be, if I already have 100 pounds and I'm making 10 pounds per hour, this equation would tell me how much money I have. And there's no way to solve how many hours have I worked or how much money I will have, but that equation tells me the relationship between those two things. And that's what you're going to do a lot of in math going forward, is studying relationships. Okay, so one thing that we can do if we want to graph this, and I showed some methods using gradient and y-intercept, but I want to go back and show you just a table of values. Okay, so you're just going to choose a table of values, and you get to choose some different values for x, whatever you want. I chose -5, 0, and 5. In other words, I'm going to investigate what happens when x equals 0, when x equals 5, and when x equals -5. Okay, all right. So let's do that. We're going to put in -5 for x. So we will have y is equal to -5 minus 3. See, I just substituted in for x. Y would be equal to -8. Okay, just put that on your table of values. And then let's investigate the next one. When we have y equals x is now 0, because we decided we were going to look at that. Okay, that's y 0, okay, because I chose. Not because any special reason. -3. Y would equal -3. Okay, cool, -3. All right, and then I go ahead and I check y is 5. Okay, so then we would have, sorry, x is 5. Y equals 5 minus 3. We just substitute in there for x, right? X just in all these cases just became the number we chose it could be. Y equals 2, and we're happy with that. So we put these points on there. This is 5, 2, 0 minus 3. I'll do them in the color coding because why not? 0 minus 3. And then -5 was blue. Okay, -5, 8. Oh, that was 6. -5, 8. There. All right. So now we've got our 3 points that we gathered over here onto a table of values. And then I just join them with a straight line. Oh my god! They all fall onto a straight line. In fact, there's an infinite number of solutions because I can choose numbers between numbers for my x values. But I'm 100% confident that if I choose a different value, like let's say -3 for x, I would get -6. Let's try it. Y equals -3 minus 3 equals -6. Hooray! Look at that. There's the point. -3 minus 6. I can even use this to solve equations like this one. See, when does x minus 3 equal 5? This is saying when is y 5? Well, y is 5. When x is 8. Oh, well, we found that too. Okay? So the algebra connects with the set of points, connects with the picture that the graph makes. All right? Now, another way to think about this line, y equals x minus 3, is to say this has gradient 1 and y-intercept -3. Because of course it does. When x is 0, y equals -3. And there it is there. There's our minus 3 y-intercept, or we call that the initial value. Okay, different words, same thing. And then the gradient is 1, okay, 1x, 1. So we go over 1 and up 1, over 1 and up 1, over 1 and up 1. 1 can be written as 1 over 1, and that's telling me the rise over the run. If I run 1 in the x direction, I better rise 1 in the y direction. Run 1, rise 1. Or indeed, run 5, rise 5. It's a proportionality of rise and run would give me the next point. So let's look at a more complex example. Y is equal to minus 2/3 x plus 6. Now, when I'm choosing x values from my table of values, you'll notice I chose things that were divisible by 3. That's a little hack for you so that I knock out the fraction and I hit integer points, because I see this one has denominator 3, okay? And I kind of don't want to deal with fractions. I'd rather deal with integers. So let's start with 0, okay? So if y equals negative 2/3 multiplied by x, but x is 0, then I add 6. Well, negative 2/3 of 0 is 0 plus 6. So y indeed equals 6 there. 6. 0, 6 is a point on this. So 0 in the x and 6 in the y is up there. These are all the x numbers. These are all the y numbers. Okay, so of course it is, because I already told you that that value always tells me the y-intercept, the place that this line will cross the y-axis. And then this one is the gradient, but we're going to ignore that for a second, and we're just going to just process a few different values on our table of values. Okay, so let's work in another color because that's fun. Let's try minus 3 here. So, no, let's try actually 3. We'll do 3 first. Y equals negative 2/3 multiplied by x, which is 3, plus 6. Well, 3 cancels 3. 3 divided by 3 is 1. Okay, so this is saying y equals minus 2 plus 6. Or if you said, what's negative 2/3 of 3? Well, that would be negative 2. Okay, and your calculator would tell you the same thing if you crunch that on a calculator. All right, and so then y equals 4. Okay, so we've got 4 there, all right? But what if that had been negative 3? So then we'll go y equals minus 2/3 times negative 3 plus 6. Well, this would cancel this, and that would cancel that, and so then we have y equals 2 plus 6 equals 8. So we have 8 there. All right, cool. Let's see what else happens. So let's try x equals 6. So we'll say y is equal to negative 2/3 of 6, which is negative 4, plus 6. Okay, so that's going to be y equals negative 4 plus 6. That's 2. And then the last one that we'll look at is negative 6. I'm just going to do it this way. If I had negative 6 there, that would be positive 4. This would be 10. Now, another thing that will happen, if you've set up your table of values like that, where all of your x values are increasing by the same amount each time, because this is a line, these will increase or decrease by the same amount each time. And notice this gets bigger by 3. Bigger by 3. Bigger by 3. Bigger by 3. And that's our gradient, okay? As this runs 3, it rises negative 2. That's our gradient. That's this negative 2/3 number, all right? Now let's put our points on there. I'm not going to be so fussy about color coding it, but we have 3, 4, this point, and we have 6, 2, and then going backwards, we have negative 3, 8, and then we have negative 6, 10. So here is our straight line that connects these points and all the infinity of possibilities in between. That would be true. If I asked, when is this equal to 0? Like 0 equals negative 2 on 3x plus 6. I can predict that that will be at the value 9, that x should be 9 here. And I can see that that's true. Negative 2/3 of 9 is indeed negative 6, so that would be 0. Okay? But visually, I can solve that problem now too. So it gives me, because I have now 3 ways of representing this relationship. I can represent it algebraically. I can represent it in a table. And I can represent it graphically. I have 3 different tools I can use for different questions, and different tools are useful for different reasons. All right. So let's also analyze this. We have y is equal to negative 2/3 x plus 6. Our y-intercept should be equal to 0, 6. Okay, just this value there. Indeed it is. And then our gradient is equal to negative 2 on 3, which is the amount it rises divided by the amount it runs. Okay, so let's look at that in some red. Here, it runs, meaning x grows bigger by 3, y will grow smaller by 2. Grow bigger by 3 in the x, grow smaller by y by 2. I can also flip that. Negative 3 in the x, positive 2 in the y. I can also go out plus 6 and down minus 4. Okay, it's a proportion. Those are a few ideas of either using a table of values or this idea of gradient and y-intercept to graph a linear equation. Give that a try. If you have more questions, absolutely send me a DM or just put a note in the topic and I'll be happy to help you out. Thanks so much for your great questions and for showing up for your learning. Bye.